Hey everyone, welcome to my YouTube channel. So I am going to cover the content is related to the aerodynamics. I will be discuss about the forces of an aircraft, flight control surfaces and high lift devices. Aerodynamics lift in an aircraft is lift basically it's an aerodynamic force that is produced by the motion of a fluid. Fluid is anything that can flow around an object or lift is that type of force that acts through the center of pressure of the object and we can also define that it is perpendicular to the flow direction. There are the four major forces which helps an aircraft to fly as it is described in the picture below. Those four forces are lift, thrust, drag and weight. Lift is that force that moves the aircraft in upward direction, and thrust is the force that moves the aircraft in forward direction, and drag is the reverse the forces the aircraft to move backward or resist the forward motion of the aircraft. Drag is basically the opposite of the thrust force, and weight is the force that moves the aircraft in downward, and weight is the opposite of the lift force. And also lift is generated by the airplane wings, and wings are shaped to make air move faster over the top of the wing. When air moves faster, the pressure of the air decreases, so the pressure on the top of the wing is less than the pressure on the bottom of the wing. This pressure difference creates the force on the wing that produces the lifts, and it lifts the wing up into the air. Wings, tail surface and even fuselage produces lift. Wings, as I discussed it earlier, that the pressure difference between the upper and lower surface of the wings creates a force on the wing that lifts the wing up into the air. And for the tail surface, as air flows over and under the tail plane, it creates lift that holds the airplane in the air. And even also fuselage produces lift. It depends upon the type of aircraft and mode of flight it is in. Modern aircrafts are made to be as efficient as possible. While this mostly means mitigating the effects of drag, it can also include generating a bit of lift for the purpose, especially at high angles of attack. We can say that almost anything can generate lift at certain angles, and wings includes ailerons and flaps. Ailerons are found on the trailing edge of the wing, typically closer to the wingtip. That means ailerons are outboard, and they are smaller in size as compared to the flaps, and it is used for rolling. This movement is referred to as roll. Flaps are inboard, and they are used to increase the amount of lift during landing and takeoff. It produces the lift that a wing produces by increasing the camber and surface area of the wing, so it increases the climb rate basically. So here in this picture we can see that the rudder is attached to the vertical stabilizer of the aircraft, and elevator is attached to the horizontal stabilizer of the aircraft. Rudder controls movement of the aircraft about its vertical axis. and this movement is called yawing movement. Like the other primary control surfaces, the rudder is a movable surface attached to a fixed surface. As I said, that it is attached to the vertical stabilizer, and the rudder is controlled by the left and right pedals. Elevators are the flight control surfaces that are usually at the rear of an aircraft, which controls the aircraft's pitching movement and therefore also controls the angle of attack and lift of the wing. The elevators are usually attached to the tailplane or horizontal stabilizer, and it basically controls the nose up or nose down movement. And this nose up or nose down movement is called the pitching movement that is done by the elevator. The distance between the leading and trailing edge of the wing measured parallel to the normal airflow over the wing is known as the chord. If the leading edge and trailing edge are parallel, so the chord of the wing is constant along the wing's length. And also many wings are not rectangular, so they have different chords at different positions. Usually the chord length is greatest where the wing joins the aircraft's fuselage, so this chord is we can call that the root chord and is represented by the CR. And the next is the tip chord, which means that the chord length is decreases along the wing towards the wing's tip, and that is the tip chord, and it is represented by CT. And most jet aircraft use a tapered swept wing design, and also average chord is the ratio of wing area to wingspan. Camber is a measure of the curvature of the airfoil, and here upper camber means the curve of the upper surface of the airfoil, and while lower camber refers to the curve of the lower surface of the airfoil. In the great majority of airfoils, upper and lower cambers differ from one another, and the mean aerodynamic camber means the mean camber line, that is an imaginary line which as in the picture we can see that the imaginary line is represented by the dotted line which lies halfway between the upper surface and lower surface of the airfoil, and we can see also in this picture that intersects the chord line at leading and trailing edges, but between the leading and trailing edge the camber line can curve above or below the chord line. Airfoil shapes are of two types, symmetrical and asymmetrical airfoil. In symmetrical airfoil, we have the upper and lower surface are identical in shape, and these type of airfoils are seen in high-speed aircrafts having symmetrical wings. However, lift is not increasing, so these type of airfoils are also known as non-cambered airfoil. And in asymmetrical or non-symmetrical airfoils, we can also known as say these type of airfoils like cambered airfoils, and both upper and lower surface of the airfoils are different in shape, um, which and it generates lift, high lift and low speed. As camber is directly related to lift, so lift increases at relatively low speed. So here in this slide, I am going to discuss about the leading edge flaps and trailing edge flaps. Flats and flaps are high lift devices that are intended to produce maximum lift coefficients on aerodynamically designed wings of aircraft. These flaps and trailing edge flaps and leading edge flaps increases the wing lift and decreases stall speed during takeoff, approach, and landing. These are normally operated with hydraulic power from left hydraulic system, and also these leading edge of the slat and trailing edge of the flap downward increases the effective camber of the airfoil, which increases the lift. In addition, the large aft projected area of the flap increases the drag of the aircraft. This helps the airplane slow down for landing. These trailing edge flaps are high-lift devices which are typically deployed on takeoff and landing to increase the lift coefficient by increasing the camber of the wing airfoil. This can be achieved by rotating the flap downwardly about its hinge line with respect to the fixed wing portion. So compared to not using any flaps, more lift is produced when the trailing edge flaps are engaged. Depending on the circumstances, several angles are employed with trailing edge flaps, and the flaps will be activated at a lower angle deflection during takeoff to produce the most lift and the least drag. Flaps will be engaged at greater deflection angles during landing to maximize drag and minimize lift. The usage of flaps has the drawback of causing early stall. Types of trailing edge flaps. Plain flap is the most simple type of flap, and plain flaps hinge to the back of the wing and they pivot down when you extend them. However, they are fairly limited in the amount of lift they can create. The reason is that as air moves over the wing, it loses energy and starts to separate from the wing. By extending flaps, the airflow separation is even more pronounced, creating a large wake behind the wing. Next is split flaps, which deflect from the lower surface of the wing. Split flaps produce slightly more lift than plain flaps, but like their plain counterparts, they also produce a lot of drag. Next is slotted flaps. It has for the two types, double slotted flaps and the triple slotted flaps. Slotted flaps basically um, can be found on both small and large aircraft. They increase wing camber like other flaps, and when extended, they open a slot between the wing and the flap. By opening a slot between the wing and flap, high pressure air from the bottom of the wing flows through the slot into the upper surface. This adds energy to the wing's boundary layer, delays airflow separation, and produces less drag. So the result is that it produces a lot of additional lift without the excessive drag. And the last one is the Fowler flaps. Fowlers are here to create the serious lift. Fowler flaps increase the area of your wing by extending out on rails or tracks. Fowler flaps often have a series of slots to add energy to the airflow as well, and they are called slotted Fowler flaps. So, in the first stage of Fowler flaps extension, there is a large increase in lift but little increase in drag, making the setting ideal for takeoff in a large jet. As they continue to extend, the flaps move downward more and more, creating a little more lift but a lot more drag. Leading edge flaps are engaged in conjunction with the trailing edge flaps, and it cannot be engaged independently. It depends on the trailing edge flaps. To guarantee the shortest possible takeoff and landing distance, leading edge flaps must be employed in conjunction with the trailing edge flaps. So the leading edge flaps don't work at varied angles like the trailing edge flaps. They either are engaged or are not. Leading edge flaps most major benefit and the goal is to prolong stalling by extending the stall angle. Here are the types of leading edge flaps: Kruger flaps, variable camber leading edge flaps, leading edge flags. Kruger flaps are lift enhancement devices that may be fitted to the leading edge of an aircraft wing. And unlike slats, the main wing upper surface is not changed. Instead, a portion of the lower wing is rotated out in front of the main wing leading edge. And the very next is variable camber leading edge flaps. That it is a feature of some of the aircraft wings that changes the camber of the main airfoil during flight. And the last is leading edge slats. Slats are the extendable high lift devices on the leading edge of the wings of some fixed wing aircraft, and its purpose is to increase lift during low speed operations such as takeoff, initial climb, approach, and landing. Thank you everyone for visiting my channel. If you have any questions, then you can ask me in the comment box.